Swayam Prabha. Digital India. Educated India.
Dear all, in continuation of ECB mode, we have to make a note of the following points. The first point, the ECB mode can also be used in encryption algorithm and maps the block length n to blocks of greater length. And clearly equal plain text blocks are encrypted into equal cybertext blocks in ECB mode. It is therefore possible to recognize the patterns of the plain text in the cybertext. This makes statistical attacks easier. If ECB mode is used, then an attacker can substitute cybertext block with other cybertext blocks that have been encrypted under the same key. This manipulation of the cybertext is hard to detect by the receiver. So, that is the point we have to make a note of ECB mode. Now, we have a pictorial representation of encryption and decryption using Cipherblock chaining mode, that is called as CBC mode. CBC mode avoids the problem of ECB mode. In this mode, the encryption of the block not only depends on the key, but also on the previous blocks. So, encryption is context dependent. Equal blocks in different contexts are encrypted differently. So, the receiver can tell the cybertext can be changed because the decryption of the manipulated cybertext does not work. So, that is a key point of Cipherblock chaining mode. Now, we are going to explain the CBC mode in detail. Cipherblock chain mode in the form of the flow chart. So, let us start with the code that is when C naught equal to 4 and then the C suffix j minus 1 and under modulo n mj of n, and then we have to encrypt EE capital EE, and under modulo n it will go to Cj, and then we have to, for the decrypts, the code is key code is given, and then corresponding DT is a decrypt, and then the process go on Cj minus 1 until the initial value of mj of original message will come. So, that is the meaning of this Cipherblock chaining mode. Now, we use the block cyber with alphabet summation is equal to 0, 1, the block length n, key space k, and encryption ek, and decryption dk, k in k. We need the following definition. So, the map XOR such that 0, 1 two tuple under domain, it maps to 0, 2 in the codomain. If you take B, C is a code, then it maps to B XOR C is defined the following table and B and C. So, the truth table like that 0, 0 and 0, 1, 1, 0, 1, 1. Now, B XOR C in the sense 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 2, under modulo 2 is 0. So, it is call it as exclusive or 2 bits or shortened XOR. So, this is the notation. You can say that. So, remember once again, it is exclusive or 2 bits or shortened form of XOR. So, now you have to take a number k, which is natural number, and B is what corresponding block B, and B1, B2 and so on k tuple, and C is another k tuple and belongs to 0, 1 of a k tuple, and B XOR C is nothing but corresponding vertices, that is B1 to C1, B1 XOR C1, B2 XOR C2, B3 XOR C3 and so on, BK XOR CK. So, this way we combine together the two tuple. So, if the elements of z integer modulo 2 that is even number are represented by their least non-negative representative 0 and 1, then exclusive or addition in z divides 2z. Now, CBC code uses a fixed initialization vector 4 belongs to summation n, which can be made public. As in ECB mode, the plain text is decomposed into blocks of length n, say m1, m2 and so on mt. Let the encryption key be E, and then C0 equal to 4, then Cj is equal to capital E Cj minus 1 XOR Mj, where j varies from 1 to t. Therefore, the cybertext is equal to C equal to C1, C2 and so on Ct. So, this cybertext can be decrypted by the decryption key D, satisfying the condition that dd of EW is equal to W for all plain text blocks W using C0 equal to 4, Mj equal to Cj minus 1 XOR ddj Cj, where j varies from 1 to t. So, in fact, M1 stands for C0 XOR ddC1, ddC1 in the sense of decrypt. So, decrypt of the C1, and then the resultant is C0 XOR C0 XOR M1, which is equal to M1, because C0 becomes 0 and then M1 only will come. Analogously, it can be shown that all other plain text are correct. Now, let us go with one example so that further you can understand. Now, the problem states that encrypt the plain text of 1011 000 1000 by CBC mode with the encryption function E pi from domain 0, 1 of power 4 tuple to 0, 1 of the 4 tuple in the codomain, defined B1, B2, B3, B4 is the code, then it corresponding to the codomain is B suffix pi 1, that is permutation 1, B suffix pi 2 is a permutation 2, B suffix pi of 3 is a permutation 3, B suffix pi of 4 is a permutation of 4 for the key pi, that is 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 1 in the permutation group, and initialization of vector 4 is equal to 1010. So, this is a key and the vector is given. Now, what you have to do is, the solution is you take a plain text that is given. Therefore, let the plain text be m equal to 10 11 000 10 100 101. Now, it is decomposed into blocks of length 4. Now, what you have to do? The last block has a length 3. Therefore, the last block is supplemented to length 4 by adding 1 0. Therefore, the plain text is m equal to 1011 001 0100, and last you have to add one more 0, that is 1010, and its blocks are m1 equal to 1011, m2 equal to 001, m3 equal to 0100, m4 equal to 1010. Now, the key is pi is equal to 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 1 belongs to S4. Now, the initialization of the vector 4 is given 1010, that is C0. Therefore, B1, B2, B3, B4 is what? B1, B2, B3, B4 is, that is 1 maps to mean B2, 2 maps to 3 is B3, 3 maps to 4 is B4, and 4 maps to 1 is B1. So, what you have to do? You have to write the Cj. What is Cj? Cj is E pi of Cj minus 1 XOR Mj. This is a rule you have to apply. Therefore, C1, the code C1 is, that is cybertext of corresponding E pi of, first one is j equal to 1 you put it, j equal to 1 mean 1 minus 1 is 0, therefore C naught, and j equal to 1 is M1, therefore C naught XOR M1. What is C naught? Already given 1 0 1 0. What is M1? M1 is C naught is 1 0 1 0, M1 is what? 1 0 1 1. Now we have to apply XOR 0 1 0 0 0. So 0 0 0 1 will come. Now what is 0 0 0 1 corresponding value? So that is you have to take the mapping of E pi of 0 0 1. So E pi of 0 0 1 is 0 0 1 0. So this way we have to calculate what? The value of C1. Now this way we have to do with C2. What is C2? C2 is E pi of C1 XOR M2. So the same way you start. What is C1? C1 is nothing but 0 0 1 0, and then just we found out, and M2 is nothing but 0 0 0 1. Now you have to XOR map, you have to do, it becomes what? 1 1 0 0. Now that is 0 0 1 1 will come. Now E pi of 0 0 1 1. So E pi of 0 0 1 1 is what? 0 1 1 0. So this way we have to calculate what? C2 value corresponding to what? CBC code. Similarly C3 is nothing but C2 XOR M3. So C2 you know already found out, this is C2. So this is C2. So this C2 apply here, and M3 already you know, and supply here, and XOR you have to do. So that is similarly XOR technique apply. Therefore E pi of 0 0 1 0 is nothing but what? 0 1 0 0. Similarly if you go to C4, C4 is nothing but E pi of C3 already got it. So take this value, and XOR M4 you technique apply, and then simply XOR technique apply to add, so that the resultant is 1110, and net value of E pi of this one is nothing but what? 1101. So this way we can calculate what? C4. Now you collect all C1, C2, C3, C4, and then you place what? C1, and then C2, and then C3, and then C4. So C1, C2, C3, C4. So that is called it as cybertext of the given plain text using the CBC mode. Is it clear? Now we have to do the decrypt. So decrypt of the cybertext using C04 is Mj is equal to Cj minus 1 XOR D capital D Cj, where j varies from 1 to t. Now you start with M1. What is M1? M1 is what? J equal to 1 you put it. So j equal to 1 you put it, C naught will come, Td of C1. So C naught you already know that value, you take it. XOR is C1 already used in the E pi inverse of this one, you have to apply it. So that E pi inverse of 0 0 1 0 is 0 0 1, and 1 0 1 0 is already simply XOR do that, so that 1 0 1 1 will come. Similarly M2 equal to C1 XOR D2 C2, which is equal to C1 XOR E pi inverse of C2, which is equal to 0 0 1 0 XOR E pi inverse of 0 1 1 0. That value inverse you take it. The inverse of 0 1 1 0 is 0 0 1 1, and corresponding C1 value is 0 0 1 0, and XOR technique apply it. The resultant is 0001 will come. So 000 is nothing but M2. The same way M3 and M4 apply it. so that you can get the plain text of what M1, M2, this is M1 and this is M2, this is M3 and this is M4. Now, the first 4 stands for M1 and next 4 stands for M2 and next 4 stands for M3 and next stands for M4. So, we can bring the plain text like this. So, this is the way we can do the decrypt and encrypt of this CBC mode, right. So, CBC mode is the technique using the permutation and then how we are initializing the 4th vector of this one, so that we can get it. Now, we will move to the next problem. Encrypt the plain text of 41 followed with 0001 followed with 0100 and followed with 31 by CBC mode with the encryption function of the map from e pi from 0, 4 of the 4 tuple to the 0, 1 of 4 tuple defined by B1, B2, B3, B4 is B pi 1, pi 3, pi 2, pi 4, mean 1 maps to 3 that is defined by key 1 maps to 2, 1 maps to 2, 2 maps to 3 and 3 maps to 4 and 4 maps to 1. So, it means 1 maps to 2, this is 1 maps to 2, it is in the place of 3, therefore, 2 maps to 3 and it is in the place of 2, then the 3 maps to 4, 4 maps to 1. So, that the vector of initial vector of 4 is represent 1110. So, this is the key given and then based on this key you have to apply, you have to find out the decrypt and encrypt of the function. Now, the given problem plain text is given. So, 41 0001 01 00 111. Now, it is decomposed into blocks of length 4 because given function 4 tuple to 4 tuple, therefore, we need length 4. Then suppose if it is last block is shortened, then adding 1 0 to the last one, so that make everything of the length is 4. Now, the last block has the length 3. So, the last block is supplemented to length 4 by adding 1 0. Therefore, the plain text is M equal to 41 001 0100 and 1110 and its blocks are M1 equal to 41, M2 equal to 001, M3 equal to 0100, M4 equal to 1110. Now, the key of pi is 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 1. This belongs to S4 mean permutation group and initializing the vector 3 1 followed with 0, call it as C0. Now, let us start. Therefore, B1, B2, B3, B4 is a what function defined and then B of pi of 1, B suffix pi of 3, B suffix pi of 2, B suffix pi of 4 is a code and corresponding it means 1 maps to 2 that is B2, 2 maps to 3 and 3 maps to 4, 4 maps to 1. Therefore, we have a block of B2, B4 and B3 and B1. So, this way we have to identify the block of this one. Now, keep it in mind this Cj is nothing but the formula E suffix pi of Cj minus 1 XOR Mj, where j varies from 1 to t. Therefore, C1 is nothing but E pi of C0 XOR M1, which is equal to E pi of C0 is nothing but what 1110 XOR 41, that is M1. Therefore, add them, we have what 0 plus 1 is 1, 1 plus 1 is 0, 1 plus 1 is 0, 1 plus 1 is 0, therefore, e pi of 0 0 0 1 is maps to 2, therefore, 0 1 0. So, that is the corresponding 0 1 1 0. So, this way because 1 maps to, next 1 maps to 3, 3 maps to 2, 2 maps to 4, like that. So, it will come, therefore, 0 1 0 0. Next, C2 of e pi of C1 XOR M2 is nothing but e pi of C1 value is, this is C1, and then substitute here, and then M2 already we taken, XOR applied, therefore, e pi of 0 1 0 1 will come. So, corresponding this mapping is goes to what, 1 1 0 0. So, this way we can calculate what the C2. So, we got it C2, right. Similarly, C3 equal to e pi of C2 XOR M3. So, e pi of 1 1 this value got it, and this value also we know that, add them, and then this is reciprocate to the value of e pi of 1 0 0 maps to 0 0 1, because 4 maps to 1, and then once again all or 1 1 comes, then it is identity will come. So, C4 is e pi of C3 of XOR M4 is equal to e pi of this is C3, C3 apply here, and then M4 value you know from the given hypothesis, and then add them, resultant is all are 1 1, 1 1 1 comes, it is identity, therefore, the net value is all or 1 only will come, because 1 maps to 1, 2 maps to 2, 3 maps to 3, 4 maps to 4. This is the meaning of the permutation corresponding to the code, and then therefore, the cybertext is first this is C1 and this is C2, this is C3 and this is C4. So, that the corresponding code of the given plain text is of the cybertext is this. Now, we have to do with the help of decrypt the cybertext by using C0 equal to 4 and Mj is equal to Cj minus 1 XOR ddgj or d capital D suffix d of Cj, where j varies from 1 to t. Therefore, M1 equal to C0 XOR dd C1, therefore, C0 XOR e pi inverse of C1. So, C0 is nothing but 1110, pi inverse is nothing but the inverse of the function is 0 1 0 0. So, the corresponding value I have to add with XOR, so that the value is 1 1 1. Similarly, M2 equal to C1 XOR dt C2, C1 XOR e pi inverse of C2, which is equal to 0 1 0 0 XOR e pi inverse of 1 1. E pi inverse of 1 1 0 is nothing but 0 1 0 1. Just now we saw that, and then use that value and substitute here and apply the XOR mapping and simply add them. 0 plus 1 is 1, 1 plus 0 is 0, and 0 plus 1 is 1, and then 0 0 is 0 will come. So, that the value of this one is equal to corresponding to M2. So, similarly, M3 value and M4 value you have to calculate. So, that the value of M1, M2 and then M3 and then M4. So, this way we can calculate the inverse of the function of the plain text is M equal to 4 1 that is M1, M2, M3 and then M4. So, original message came, therefore, the proper message conveyed, and then we can do with encryption and decryption. Now, another problem with different code, encrypt the plain text of 0 0 1 1, 0 1 1, 0 1 0 1 1 0 by CBC code of CBC code, that is mode, with encrypt the function e pi 4 tuple 0, 1 to 4 tuple 0, 1 defined by B1, B2, B3, B4 is nothing but 1 maps to 2, 2 maps to 3, 3 maps to 1 and 1 maps to 4 for the key, that is 1 maps to 3, 2 maps to 1, 1 maps to 3 and 2 maps to 1 and 1 maps to 3, 3 maps to 2, 2 maps to 1 and then 4 is identity. So, like that they defined the code. This is the permutation given and initial vector the 4 is 0, 1, 1, 0. Now, the plain text M is given and then one more 0 you have to add with the last one. So, that the last block has the length 3 and the supplemented to the length 4 by adding 1 0. Therefore, the plain text M is equal to 0 0 1 1, 0 1 1, 0 1 1 0 and 1 1 0. Here one more 0 added in the last digit. So, that it has 4 blocks. So, the blocks are first one is M1, second one is M2, third one is M3, fourth one is M4. Now, you take the permutation. What is the permutation? 1 maps to 3, 3 maps to 2, 2 maps to 1, 4 maps to 4 is a permutation of S4. Now, initial vector is 0 1 1 0 which is equal to C naught. Therefore, the block that is the defined by the function is B1, B2, B3, B4 should be like that. That is B of pi of 2, B into pi of 3, right, and then B into pi of 1 and B into pi of 4. That is 1 maps to 3 and 3 maps to 2, 2 maps to 1 and 4 maps to 4. 4 is identity here. Now, the rule for finding the Cj is E pi of Cj minus 1 XOR Mj, where j varies from 1 to t. Therefore, C1 is E pi of C naught XOR M1, where E pi of 0 1 1 0 XOR 0 0 1 1. Therefore, add them, we have what 0 0 1 0 is 1, 1 1 is 0, 0 1 is 1. Now, with E pi of the fourth one is because it is identity, fourth one is identity. Therefore, E pi of this one is 0 1 0 1 will come. And the next C2 is nothing but E pi of C1 plus symmetric difference M2. Therefore, E pi of 0 1 0 1 XOR 0 1 1 and then add them XOR 0 0 1 0. So, net value is the same will reflect because the identity in the fourth. Similarly, for C3 and C4. So, C1, C2, C3, C4 we deducted and then that is the ciphertext of a given problem. So, now we have to do with the decrypt of these ideas. So, for decrypt the ciphertext using C naught equal to 4 and then Mj equal to Cj minus 1 plus Dd of Cj. So, for C naught you know and Dd of C1 is we already done it for E pi inverse of C1, that is backtrack you take it. So, that E pi inverse is back is 0 1 0 1 0 1 0 1 and then using the symmetric difference XOR mapping, using XOR mapping. So, that add them we have this value and corresponding simply add 1 1 and then 0 0. So, similarly M2 M1 will come, M2 will come, M3 will come and then M4 will come and then the 4 value we can write the corresponding plain text of the given problem. Therefore, we done for encryption and decryption of the given function. So, up to this I stop it.